Today we will discuss some questions. The first one you can read like this: a charge is enclosed inside a Gaussian surface of irregular shape. What will be the total flux passes through the surface? So you can see an irregular shaped Gaussian surface over here. A charge Q is kept inside, and question is what is the flux passes through the surface? The Gauss's theorem says that the flux passes through any Gaussian surface is equal to 1 by epsilon 0 times the charge enclosed. Therefore, flux passes through the surface phi will be Q by epsilon 0. Now imagine another charge is kept here, Q, outside the sphere, outside the Gaussian surface. What will be the flux? Outer charges will never contribute to the flux. Therefore, the flux remains same. That will be Q by epsilon 0 itself. Now, if I am considering another charge Q inside, now what will be the flux? There are two charges inside, both are positive. Therefore, flux phi becomes Q plus Q. That will be 2Q by epsilon 0. Now, if I am considering this particular charge is negative, what will be the value of flux? Phi becomes 0 because the charge inside will be Q minus Q, that will be 0. Therefore, flux phi is equal to 0 by epsilon 0. That will be 0. Question number 2, you can read like this. A charge is enclosed in a Gaussian surface of radius r. What will be the value of the flux if the radius of the surface becomes 2 times? So you can see there is a Gaussian surface, radius r, a charge is enclosed, and question is, if I am doubling the value of the radius, what will be the flux? The flux phi, according to the Gauss's theorem, flux phi is equal to Q by epsilon 0 only. The flux does not depend upon the size and shape of the Gaussian sphere or any Gaussian surface. It depends only on the amount of charge inside, magnitude of the charge inside. Therefore, as far as magnitude of the charge inside remains same, no matter whether the radius become double, the flux remains same. There is no change in the flux. So that is question number 2. The next question you can read like this. So a charge 10 microcoulomb is placed at the center of a square of side 10 centimeter. What is the magnitude of the flux passes through one surface? So this is the square, side of the square is 10 centimeter, and a charge is placed inside this is a cube actually. A charge 10 microcoulomb is placed at the center of a cube of side, not a square of side, sorry, this is cube. So this is that cube, side of that cube is 10 centimeter, a charge Q is enclosed. According to Gauss's theorem, what is the total flux passes through the entire surface? The total flux passes through the entire surface phi is equal to Q by epsilon 0. Now let us consider how many surfaces are there. In the case of a cube, how many surfaces are there? 6 surfaces are there. Left surface, right surface, top surface, bottom surface, front surface and back surface. Altogether 6 surfaces are there. The total flux passes through all these 6 surfaces, and the question is what is the magnitude of the flux passes through one surface? So any one surface, maybe front or maybe back, whatever it may be, any one surface, what will be the magnitude of the flux? The magnitude of the flux passes through one surface will be 1 by 6 the magnitude of total flux. Therefore, flux passes through one surface will be 1 by 6 the magnitude of total flux, that is Q by epsilon 0. Therefore, 1 by 6 into Q, the charge is given 10 microcoulomb, therefore it will be 10 into 10 to the power minus 6 divided by epsilon 0, that is 8.85 into 10 to the power minus 12. The answer will be 1.9 into 10 to the power 5 Newton meter square coulomb raised to minus 1. So that will be the flux passes through a single surface. Now let us discuss another problem. You can read the problem like this. A charge q is placed at the center of two hemispheres of radius r and 2r as shown in the figure below. Prove that total flux passes through the entire surface is q by epsilon 0. Now you can see this is the hemisphere, bigger hemisphere of radius 2r. This is the smaller hemisphere of radius r, and a charge q is placed at the center. So the Gauss's theorem says that the total flux passes through the entire surface must be equal to q by epsilon 0. That we have to prove. First of all, let us take a smaller hemisphere. Where is the smaller hemisphere? This is the smaller hemisphere. Radius of the hemisphere is r. Now, what is the flux passes through the smaller hemisphere? That's a question. We know that flux phi is equal to integral of E dot ds. So wherever I am taking a small elemental area ds, electric field and elemental area are parallel to each other. E and ds are parallel to each other. Therefore, angle between E and ds are 0 only. As well as everywhere on the smaller hemisphere, electric field remains same. Therefore, electric field I can take out of the integration. Therefore, the flux phi can be written as phi small r is equal to E into integral of ds, where integral ds means the total surface area of the smaller hemisphere. So the total surface area of the smaller hemisphere will be 2 pi r square, half of the surface area of a sphere of radius r, because it is a hemisphere. Now what is the magnitude of electric field at this particular point at a distance small r from the center, from the charge? Electric field magnitude will be 1 by 4 pi epsilon 0 q by r square. Put as equation number 2. Now let us substitute 2 in 1. We will be getting phi small r is equal to 1 by 4 pi epsilon 0 q by r square into 2 pi r square. Cutting the values from the numerator and denominator, will be getting phi smaller is equal to q by epsilon 0. So this is the total flux q by 2 epsilon 0. Sorry, this is the total flux passes through the smaller hemisphere. Now let us consider bigger hemisphere. What is the total flux passes through bigger hemisphere? So here also in the case of bigger hemisphere, anywhere I can take an elemental area ds. The electric field will be radially outwards like this E, and ds vector will be like this. They are parallel to each other. Angle between E and ds is 0. Therefore, cos component will be can be eliminated, as well as electric field having the same value everywhere. Electric field is a constant one, can be taken out of the integration. So flux passes through the bigger hemisphere can be written as E into integral ds. Now what is integral ds? Total surface area of the bigger hemisphere, that will be 2 pi radius square. Bigger hemisphere radius is 2r, therefore 2 pi 2r the whole square. So 2 square, it will be 4, 4 into 2 8, E into 8 pi r square, that will be flux phi b. Now I have to substitute for E. What is E? Electric field on the surface of the bigger hemisphere. So 1 by 4 pi epsilon 0 charge into distance square. Distance will be 2r, radius will be 2r. Therefore 1 by 4 pi epsilon 0 q divided by 2r the whole square. So that can be written as 2 square, it will be 4, 4 into 4 16, 1 by 16 pi epsilon 0 q by r square. Put as equation number 5. Substitute 5 in 4, you can see phi b is equal to 1 by 16 pi epsilon 0 q by r square into 8 pi r square. Cutting the values from the numerator and denominator, phi b becomes q by 2 epsilon 0. So flux through the smaller hemisphere will be q by 2 epsilon 0. Flux through the bigger hemisphere will be q by 2 epsilon 0. Therefore, total flux phi is equal to phi s plus phi b, that will be q by 2 epsilon 0 plus q by 2 epsilon 0, that will be flux phi is equal to q by epsilon 0. So total flux passes through any Gaussian surface of any shape, that will be q by epsilon 0 according to Gauss's theorem. Let us consider one more question. What is the net flux of a uniform electric field E is equal to 2 into 10 to the power 3 I Newton per Coulomb? through a cube of side 20 centimeter cube. So here, to cube of side 20 centimeter only. Here you can see there is an external electric field 2 into 10 to the power 3 Newton per Coulomb I. I means the electric field is acting in the x direction. And there is a cube of side 20 centimeter. So this is that cube. This is a cube of side 20 centimeter. Since electric field is in the positive x direction, and you can see how many surfaces are there. There are 6 surfaces. Electric field and area vector will be perpendicular here on the top surface, and here on the bottom surface, here on the front surface, and here on the back surface. So these 4 surfaces, electric field and area vector are perpendicular to each other like this. Electric field and area vector are perpendicular to each other like this. So if electric field and area vector are perpendicular, the flux will be cancelled because theta is equal to 90 degree, there will be no flux. So 4 surfaces will not contribute to the flux. The flux contribution is only due to 2 surfaces, left surface and right surface. On the left surface, I am taking a small elemental area. Area vector will be like this. Electric field will be like this. Angle between E and DS is 180 degree. On the right surface, I am taking an area vector, elemental area. Area vector will be like this, and electric field will be like this. Angle between E and DS is also is 0. Here it is 180 degree. Here it will be 0 degree. Now the total flux can be written as phi is equal to integral left surface E dot ds plus integral right surface E dot ds. Expanding integral E ds cos of 180, because angle between E and ds on the left surface is 180, plus integral E ds cos of 0, because angle between E and ds on the right surface is 0. All other surfaces, electric field and area vector are perpendicular, that will not contribute to the flux. Since it is uniform electric field, E can be taken out. You can write in minus integral E ds, because cos of 180 is negative minus 1. Here it will be integral E ds. E can be taken out. Minus E into integral ds plus E into integral ds. Integral ds is nothing but area of this particular plane. Let it be A, as well as area of this particular plane. Let it be A. So integral ds is equal to A. Therefore it will be minus EA plus EA. Phi is equal to 0. This result is expected because there is no charge enclosed. If there is no charge enclosed, flux will be 0. This electric field is due to some other external charge distribution. The external charge distribution will never contribute to the flux. One more question we can discuss in this video lesson, that is, you can read like this. Consider a uniform electric field 3 into 10 to the power 3 I Newton per Coulomb. What is the flux of the field through a square of side 10 centimeter whose plane is placed parallel to YZ plane? B part of the question is, what is the flux through the same square if normal to that plane makes an angle 60 degree with the x-axis? So there are 2 cases. One is there is an electric field. 3 into 10 to the power 3 is the magnitude of that electric field. Direction is I. You can read direction is I. Positive I means I cap means x direction. Minus I cap means negative x direction. J cap means y direction. Minus J cap means negative y direction. K cap means z direction. Minus K cap means negative z direction. Okay. Now here we have to find out the flux through this particular square, and the square is placed, whose plane is placed parallel to the YZ plane. Where is the YZ plane? This is the Y axis, this is Z axis, therefore this plane is YZ plane. Okay, the square is placed parallel to the YZ plane means the area vector of the square is always perpendicular to the plane, that will be in the x direction. So in the case number 1 or first case or A, angle between electric field and area vector is 0. Therefore, flux phi is equal to E dot A. Here there is no integration needed because we are not taking any elemental area. We are taking the area as a whole. Therefore, there is no integration. Phi is equal to E dot A is equal to E A cos of theta. Theta is equal to 0 here. Therefore, it will be E A only. Electric field is given E is equal to 3 into 10 to the power 3. Therefore, I can substitute 3 into 10 raised to 3 into 10 into 10 raised to minus 2 the whole square, because area is equal to length square. Length is given 10 centimeter. Therefore, 10 into 10 raised to minus 2 the whole square area. Therefore, the result will be 30 Newton meter square Coulomb raised to minus 1. The B part of the question you can read like this: what is a flux through the same square if the normal to that plane makes an angle 60 degree with x-axis? Now the square is not placed like this. Instead of that, the square is rotated so that normal to the plane of the square makes an angle 60 degree with x-axis. Electric field is in the x direction. Okay, now you can see what is the angle between electric field and area vector. 60 degree is the angle between electric field and area vector. Therefore, the flux through the square right now will be EA cos of theta. Here theta is equal to 60 degree. Therefore, EA we already calculated 30. Therefore, 30 into cos of 60. Cos of 60 will be root 3 by 2. Therefore, answer will be 15 root 3 Newton meter square Coulomb raised to minus 1.